Alrighty, let's go ahead and do a practical hands-on lab or a live build. Here's what we're going to build. It's essentially a relatively simple document loader that will upsert our document, which in this case is the entire Gitbook, or we'll do a couple of Gitbooks, so a couple of documentation sets. These will go into our Supabase vector table. From there, we will be able to have a basic conversation, which, as you can see here, it's essentially I've upserted Gitbooks for TypeScript and JavaScript, and also another one on how to create operating systems. And so here I'm asking, is it possible to do an operating system with just JavaScript and TypeScript? The model is able to respond and tell us, no, basically it's not really possible to do that. Okay, let's name this demo Langmasters Supabase Upsert chain. This will actually be a chain and not an agent or conversational set. So first, let's create our node arrangement. Let's start with the chain itself. This will be a conversational retrieval QA chain. Whoa, it blows it up. Let's back out so that we can see our canvas. I'm going to place that there. Let's grab an LLM. In this case, you can use either a chat model or an LLM. For demonstration purposes and in future lessons, we'll be using a separate chain to chat and have more sophisticated conversations with our databases. Here we can use something simple, just a straight LLM module instead of chat version. So as you could see, the way you could tell that it's the non-chat is that if you click here, you only see these legacy GPTs. They don't have chat functionality. You ask a question and they give you that. Okay. So then from there, we will need our Supabase node and make sure that in this case right now we're using the Upsert document. So we'll put that here. Okay. So we're almost there. Let's keep going. Since we have a chain, we're going to need the language model here. Then we're going to need the vector store here. We're actually not even going to use a memory here because this isn't really a more complex chat-based thing. It's very primitive. So we're definitely going to need an embeddings node. And for that, we're going to use OpenAI because we will be working with the 1536 cosine embeddings, which OpenAI uses. So let's connect the embeddings here. And for our actual data source, we're going to be loading from Gitbook. Okay. So the Gitbook is going to, the document, is going to go here. And then the last thing we need is a text splitter. And we will be using the recursive character text splitter. So let's do that. All right. Next step, let's do the credentials. GPT 3.5 Turbo Instruct, that's great. Temperature, for stuff like this, temperature always matters because you're essentially telling the model to either be completely deterministic and dry or to employ what it considers to be creativity. So let's add the key here. We will strip new lines. Chunk size at 1,000 is fine. And then we will use the chunk overlap value of 50. Okay. And then for the credentials for our Supabase, so the actual credential goes here. Now we need a couple more things. And before we enter these, actually, let's go ahead and set the default here. Before we enter these three values, we're going to need to jump over to our Supabase instance and actually create the stuff. If you are completely non-technical, it'll be a little bit of a new territory for you. But if you have an SQL background, this should be very self-explanatory. What I have here is the documentation from Supabase that gives us the template to use. You'll want to go to your SQL editor. And as you could see here, so let's just back up for a second. Inside of our table view, you could see that I already have a documents table that's just empty. And then I have this demo documents table, which we could use for these purposes. But since we want to go through the full experience of creating one, we will create another one. Once we're here, we have our queries, right? And there's all sorts of different ways you could do these. You could only have a couple and then change out the information in them using these as templates. Or you could have separate ones and keep the unique information in each one. There's really no foldering system and it's difficult to keep track, so it might make sense to do it like this. As you can see, I have one for creating tables and one for creating functions. So we'll go into this create table one. And you could see that right now it contains the instructions from the table that I had just created. And where I got that is from the documentation. First, you will want to enable the vector extension. I've already done that. So it'll just give me an error saying this has already been enabled. But if you haven't done that yet, run this extension first. You don't need to include the commented outline. You can simply use the SQL itself. So what we will go ahead and do is use the second part, only instead of naming our table documents, again, which you can, or you can name it whatever you want. And again, that'll depend on your project or what exactly you're building. Perhaps you will have tons of different tables for different kinds of documents, or maybe you'll just have one big master table. So for our purposes, we will just incrementally give this one a 2. As you can see, this here is the same as this, right? We're telling it to create a table. We will have a column that is the ID of the row, and it's of type big serial, and that will be the primary key. We will have the content column itself that is of type text, metadata column that is of type JSON binary, and then the actual number-based embedding column that will contain the coastline vectors. demo docs. Again, please, if you try to do this and use dashes, that's going to give you an error. See? And what's kind of cool, well, what's actually been really nice about Supabase is that their debugger, it works quite well. So if you click this, it's quite similar to Copilot in VS Code. So you could see here, it's telling us, yep, make sure to use underscores. So we could either accept this change or we can just discard it. So I'll accept it, done. Automatically rewrites it for you. And this time if we run it, excellent. Success. This is normal. Why would we return any rows? Because we just created a table. So no rows returned is what you want. Okay, and then you go to your table view, and right away you're going to see this brand new vectorized table. Next, let's run the third part here. And what I will do is just jump into the function naming one. Here, we are going to need to change a couple of things. If you look at the template, it's mentioning documents because that is what the original table, the template name is called, documents, in a couple of places. The only real thing that needs to be done is that wherever it says documents, you need to make sure that you replace that with the name of your table. So in our case, right now, it's going to be demo docs 2. Okay. This is a code SQL statement for creating a matching function. So this is what's actually going to help us find what we need when we're talking to our agents or chains. And if we scroll down, this is the next place that asks for the name. We change this to 2, and here to 2, and finally here. Okay? Make sure your names line up, otherwise it won't work and it's gonna fail. Okay? I'm gonna run this. Success. We did things correctly, and the way that you can verify the functions is you go to database, functions, and scroll down, boom, right here. You see all 3 functions have been created successfully. Okay, so now that the Supabase part is done, we can come back here. First, it wants us to put our project URL that you will find in settings under API. And here's your project URL. Just a random string, supabase.co. Put that here. The table name. Again, make sure to use whatever table name you created. So in our case, it's demo docs 2. And then the query name. So just to verify, always good to do a quick sanity check. The query name is match _ demo _ docs _ 2. What we've done so far is instantiated a chain, connected basic LLM to it, set a relatively conservative temperature, set up our data source loader, and you will see here, while prototyping and creating this chain, you have access to this link. On the front end, when you're implementing, you can customize this and add additional links or just push a link, click submit, and then keep changing links to keep adding documents to your table. So just to show you, as you could see in the demo docs 1 table, we have 1,151 records, right? So this is already what I've sent through this chain before. Demo docs 2 has 0 records. So it's a new clean table. Let's go ahead and add our source now. Sure to save. I will go here, and this is a Gitbook for TypeScript deep dive. So it's given us quite a bit of useful information, and perhaps if you're a TypeScript programmer or have a TypeScript background, you've come across this resource before. It's wonderful. Simply copy paste here. You do want to load all paths. That way it scrapes the entire Gitbook. And then just make sure you check all the parameters here. I'm not going to worry about that right now. And of course, 2 important things. So return source documents. Yes, let's do that, because this way it will actually show us where it got the information. And then here, we also have the ability to add our identity as we have done before. So I have this saved. Okay, so like this. And then we'll select. You have a couple of options here. Tells you what they do. For now, it's totally fine. Let's just use this top one. And if we go into the identity planner, so you could see what we're doing here. We're asking it to be a specialized interactive document, named whatever you want to name it. And we're essentially giving it a job. You will engage with me in conversational manner. So again, we're not using a conversational chain, but we can, we're not using a chat model, but if we replace it, essentially just will be a bit higher quality. Okay, so let's go ahead and test this. What will happen now is the following. When we initiate the chain, it will send the information from this link into our table and allow us to then ask questions. Yeah, what I have found is to actually do the conversation loading, so to speak, or when you're using multiple vector stores, if you're in a bigger production environment or running real projects, you will probably want to use a separate flow sequence altogether. So there you will not be upserting things, you will actually just be using the load variants. So for example, if you go to Supabase and search for it, or search for the Supabase, you see that there's this upserter and then there's the loader. Same with Pinecone. There's an upsert one, there's a loader. Same with Chroma. So upserting simply means sending it in. Loading means taking it out. Okay, so I'll save one more time and let's see what happens. I will simply ask, are there ever instances in node-based programming where you would want to use plain JavaScript over TypeScript? And yeah, let's give it a second because it does have to initially submit this information into our table here. Again, in more real production scenarios, you probably will have the process of sending information quite separate. It could even potentially won't live inside the world of Flowise, and you could just use direct API calls or SDKs and send in much larger pools of information into your data lake, right? But since we are learning here about how these kinds of flows and node connections work, we are using the Upsert module directly. What I have noticed is that it can be quite slow, both on the local and if you run this on Railway. It almost feels like it's hanging up and, is it going to produce some sort of error? But no, this is just the time it takes. So I'll let this run and I'll be right back. Alrighty, and we're back. So as you can see, because we fed this information that's really strictly TypeScript related, we have successfully sent the data into the demo docs table, right? You could see 523 records and the actual content that went in, the metadata, and the numerically represented versions. Let's do this. If we go to another Gitbook, but this one is specifically for JavaScript. We're giving this specific chain both flavors. I'm going to back out, close the chat, enter a new link, still load all the paths, and change nothing else. Return source documents, and then we will save. A good tip is before you run your agents, if you just are moving a little fast and you have that asterisk here, just look in your top left corner, and if there is an asterisk, save it and get rid of it, so the chain is 100% in the updated state. Let's ask it the same question and see if it is still giving us this dumb response, or if it actually can first send in the additional records. Okay, so question is no. So why don't we ask something different? Can you tell me the main 3 differences between TypeScript and JavaScript? You could see the speed here, but it looks like the new vectors have not really increased all that much. So it's unclear exactly how much of the information from here has gone into our table. As you could see in my previous demo docs table 1, where I essentially loaded the same links, we have over close to 1,200 records. So I'll one other link here. This is Gitbook on kind of the basics of how to make operating systems, right? So we'll delete this. We will save. And actually, why don't we do this? Like, erase, clear the entire chat history. Okay, kind of a reset point. And now I will ask a different question. Let's say, can you, is it possible to create an operating system using just JavaScript and TypeScript? We have reset this chain, added a third source, and it's sending the data into Supabase, creating the vectors,